The purpose of this video is to give you the understanding of how to measure 3-line voltages and single line voltage using this isolator just here. It's what you're going to be doing in your 204 assessment. First of all, what I'm going to do is I'm going to introduce the equipment that we're going to be using. This is what we call a multimeter, and it's got various different settings on there which you can use for measuring ampage, ohms, resistance, and obviously the voltage. Now, because the voltages that we're going to be measuring can be up to and exceeding 400 volts, we need to make sure that we're using the appropriate setting on your meter, otherwise you could damage it. Moving on to that then, we're going to look at the meter settings. Okay, we've got the test leads for starters. You need to do a visual inspection on these. We're checking for any kind of damage, if they've been cut, or if there's any kind of copper showing, or they've been crushed. No, the leads are fine. You'll see here, I've got 2 attachments. Should you use these leads as they are at the moment, that is exceeding the maximum amount of exposed tip that you're allowed. You'll see that we've got finger guards fitted. The purpose of these is to stop your finger from slipping down and obviously touching live or exposed conductive parts. What we can do is we can fit simply an attachment here, which only gives you, I'll come a bit closer, it only gives you 2 mil of exposed tip. That is obviously a lot safer than that. Let's say you're testing and you've like that, obviously you can touch the tip. When that's on, obviously you've got no way of touching it unless you directly touch the tip there. Okay? Right. Now we've looked at the leads. Okay, we've talked about those. We'll look at the meter settings themselves. You've got, obviously it's in the off position at the minute. We need to go to 750 volts, and there is a line that you'll see behind it, because there's 2 types of voltages you can measure. There's DC and there's AC. AC is represented by a sinusoidal waveform, and then DC is given to you as a direct straight line. Okay? So the setting that we're looking for on the actual meter itself, we look around the edge here. The first orange or beige is talking about ohms, so that's resistance. The next one also ohms, so we're still on resistance. Then it goes to 1000, but it's got that straight line, so we're still on the DC. We're going to be measuring AC voltages. So we need to see this little one here called, it's 750 volts voltage AC. Now that means that this meter, when you're using it, you can measure up to 750 volts. Now the voltage we should be measuring should not really exceed 400 to 440, which we'll talk about in a little bit more detail later on. That's the setting that we're going to be using. Okay. When I'm measuring, what I'm going to do is, just so as you can see a little bit easier, I'm just going to put that onto there, and the appropriate display of voltage will be highlighted just here. Now we've done that, we need to obviously be made aware of the hazards. There can be up to and over the region of 400 volts within here, so you must feel safe, you must feel confident carrying out this kind of work. If you make any kind of silly mistake, well, 50 volts can kill you, so as sure as having 400 volts is not going to do you any good. So, what we've got on the board here is basically you could almost call it a circuit diagram of the actual isolator's insides itself. Okay, we've got 3 lines which are coming in. It's actually fed from underneath, fed by the Armaflex here, which is plugged into a 3-phase isolator behind with an RCD backup. So the supply comes into the bottom here. Okay, now these 3 fuses just there, they're what we call BS88 type G, general type. Okay, this type of isolator will be used in more industrial and commercial premises. It's not as sensitive as your type B, C breakers, but obviously it does still give you a means of protection. So now that we know the type of fuses and the supply coming in, we have what we call a neutral link here. Now this neutral link can be undone and released for isolation from the neutral conductor. Okay, we've also got the earth terminal I'll just turn this off here. We've also got the earth terminal, which is located just to the right hand side by a mechanical joint. So there's your neutral link as we've discussed. Now if we pull this off, this can be taken off by all means, but there are our 3-line supplies. These terminals will not be live when the isolator is turned off, but when the isolator turns on, the contactors come into play. So when it's off, the top terminals will be dead, okay, or isolated. It's the bottom terminals that we need to be taking our measurement from. So you've got a brief understanding or a basic understanding of the layout of the isolator, how it functions, okay. What we're going to look at now is how do we measure the voltages across all of this and what are we expecting. So prior to this, we need to know what kind of values are acceptable. So we talk about nominal voltages. Now nominal voltages in the UK for a 3-line voltage in the region of 400 volts is the set standard. It used to be 415, now it's gone down to 400. The single line voltage, you would expect to have 230 volts. Again, that used to be 240. It's now been slightly reduced for the harmonisation with European standards. So that's what we're expecting. Now what we need to do is, we need to talk about the limits. It basically states that you're allowed plus 10%, minus 6%.